Your pipeline fails with error parsing JSON, but only some days. A new data source sent JSON with missing fields, and try parse JSON returned null, breaking your where clause. Let's explore. You'll learn how to define variant columns, load JSON/Parquet/Avro data, query nested structures, flatten arrays, and optimize performance. We'll also cover a real production incident and provide a debugging guide. Snowflake's variant data type lets you store and query semi-structured data like JSON, Avro, Parquet, and XML directly using SQL without needing a predefined schema. Think of it like a magic box that can hold any somewhat messy data, and it's internally compressed and columnar for efficiency. To define a variant column, use the variant data type in your create table statement. This column can hold any semi-structured value, and importantly, you can mix objects, arrays, scalars, and even strings all in the same column. Here's a simple table with a variant column and an ingested at timestamp defaulting to current timestamp. You can insert any JSON, Avro, or Parquet data into event data without preprocessing. Snowflake supports loading semi-structured data from internal or external stages using copy into. You specify the file format, like JSON, Avro, or Parquet, and for JSON arrays, use stripout_array equals true. The data loads into a variant column, then into the events table. First, create a file format specifying the type as JSON. Then, use copy into to load data from your stage. The stripout_array option loads each object in a JSON array as a separate row. Snowflake provides dot notation to access fields in a variant. Always cast the extracted value to a native type using double colon. For better performance, most often to varchar. We insert a JSON object using parse.json, then query it with dot notation. Notice the double colon to cast to varchar and int. For arrays, use bracket notation with index. When your data contains arrays, use lateral flatten to expand each array element into its own row, and with outer equals true, you preserve empty arrays, essential for analyzing nested data. We insert sample data using parse.json to create an items array, then flatten it. Flatten expands each array element into its own row with value and index columns. Parquet and Avro, columnar formats common in data lakes, are loaded into variant columns using copy into, similar to JSON. Schema can be inferred automatically or discovered via Infer Schema. Use the Infer Schema function to discover the column names and types in your Parquet files before querying. Querying variant columns can be slower than native columns. Optimize by always casting explicitly, creating materialized views for frequently accessed fields, filtering rows early, and avoiding deep nesting, delivering a fast result. If you frequently query the same field, create a materialized view that extracts it into a native column. This avoids repeated parsing and speeds up queries. Semi-structured data stored as variant often has missing fields. Use try_parse.json to safely parse, COALESCE to supply defaults, and array size to check if an array exists before accessing elements. We safely extract a potentially missing field using COALESCE to provide a default. For arrays, we call array size to confirm elements exist before accessing the first one. Real-world data often has deeply nested structures in a variant column. Chain multiple lateral flat calls into the orders array, then items array, alias each level, limit to 2-3. Then reach a final level like product and price. The example uses parse.json for sample data and lateral flat to unnest the orders array, then their items. Aliases keep the query readable. Here's how it played out. A developer assumed all JSON fields were always present. A new data source occasionally sent objects with missing fields, causing try_parse.json to return null, which then failed in a where clause that expected a non-null value. Starting with the JSON source loaded into a variant column via copy into, the fix was to add COALESCE and explicit null checks. For instance, in the where clause, COALESCE, data field, equals ensures missing fields are handled gracefully. Always handle nulls explicitly in semi-structured data queries. That leads to success. This is the exact mistake from the incident. A missing field returns null, causing the where clause to fail. As shown in the fix, wrapping the field in COALESCE replaces null with an empty string, so the comparison works correctly. Without explicit casting, event data, username remains variant, slowing down queries and breaking joins. Adding, VARCHAR casts it to a native string, enabling efficient joins and aggregations. Without outer equals true, Flatten excludes rows with empty or null arrays. Adding outer equals true, as in the fix, preserves those rows by returning null. To debug semi-structured data issues, start by checking the field path using GET or dot notation. Use TYPEOF in conjunction with lateral flatten to verify the data type. For loading errors, use validation mode to identify bad rows. Time for common interview questions about Snowflake semi-structured data. Be prepared to explain variant, notation differences, and flattening techniques. Let's walk through frequently asked questions about Snowflake semi-structured data handling. To recap, Snowflake's variant type allows flexible storage and querying of semi-structured data. Use dot notation with casting, flatten arrays with lateral flatten, handle missing fields gracefully, and optimize with materialized views. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.